All right, so the question says, given the following code, build a process tree, right? And there's multiple fork operations in it, and we call this the fork problem. So one thing that kind of helps is first numbering, because when you fork, different processes start with different lines. So it might be helpful to like first label the nines from 1 through 9, and then now we can start it, right? Another thing that helps is labeling each fork. So that's A, that's B, that's C. Wherever I see a fork, I just label it. And now we're ready to start the process tree, right? So first you have the original process. The original process is just there. So this one, there's gonna be a lot of explaining, so I'm gonna try my best to write it all down. This starts at line 1. Okay, all right, cool. In line 1 it starts, then it forks. So it forks and it makes A, because it forks, it's on this one, right? So it forks that. Next, we're not going to move to A, we're going to stick with the original process. Then it comes to this line, it forks again, so that's B. So there we go, and that's B. Now it's B, but this fork is different than this one, right? Because when you fork this, a value gets stored into num. So the process calling the fork is the parent process, and the parent process will always have a value of 1. The child process will have a value of 0, right? Whew. So since this fork, this process is forking, that means num here is 1. So original process num is equal to 1. All right, then the next line, we did line 1, we did line 2. Next one is line 3. Line 3 says cout 1, so you're going to cout 1. Next we're on this line. If num is greater than 0, then we enter this loop. Is num greater than 0? Yes, num is 1 for us, so 1 is greater than 0. So we're here now. We're going to fork again. This time we're forking C. So I'm going to extend this one, and then I'm going to fork C. So we're on line 6. Next, cout 2. So we're going to cout 2. Next, that's nothing. We're going to cout 3. All right, cool. Cout 3. So now that the original process is done, we could just put a tick mark there, right? Next, we can move on to process 1, A, B, and C. So I'm just going to move this here, just so it's obvious that these are 2 separate steps. Next step, when we actually get to do the problem, you don't have to like make it into 2 different things. I just did this just for the sake of the video. Cool? All right. Next up, we have A. So A, it was the child process of the original process, right? This is the child of that. Original process started at line 1. So this line is not what A is going to start off with. A is going to start off with this line. So let me change colors. Green is fine. So A is going to start off with line 2. So A will now fork again. It's going to fork B. So I'm going to do that. It's going to fork B. All right. But this time, it's also a bit different, right? When you're forking, you're storing a value in num. This A is the parent process of B. So when it's forking, the num here is going to store 1 because it's the parent process. So in this one, start line 2, num is equal to 1. Num is equal to 1. So we're here now. We did that step. So I'm going to num is equal to 1. All right, cool. So we did line 2. So we're at line 3 now. Cout 1. All right, we're going to cout 1. Next, if num is greater than 0, we're going to fork, right? We're going to fork. So what is our num value? Our num value is 1. Is 1 greater than 0? It is. So we're going to fork again. So this time we're going to extend this one. we're gonna fork C. I'm on this line, by the way. Enter this line because num for us is 1. So we're done with line 6. Let's move on to line 7, which is C out 2. So let's C out 2. All right, cool. Next, 8 is a bracket. 9, C out 3. All right, let's C out 3. All right, so now we did process A. So that's done and dusted. Let's move on to B. So what's B doing? B was also called from the original process, and B will start at line... What line will B start at? Let's see when B was called. B was done in this line, right? So B will start at line 3. So, different color again. I'm running out of colors. So B starts line 3. All right, so at line 3, what do we say? We're going to C out 1. All right, C out 1. Num is greater than, if num is greater than 0. So now B is not calling any forks, right? Like B is the child of the original process. That this parent process will have a num value of 1. This child process will have a num value of 0, right? That means our num is 0. Is 0 greater than 0? It's not. So we don't enter this loop. We skip straight to line 9, which is C out 3. So we're going to C out 3. Since we reached the end of the program, we're done. So let me move that there. Let me make this arrow like that. And let me change colors. We're done with B. All right, cool. Next. Different color. There we go. Next, we're at C. So C, when was C called? The original process started at line 1. Okay, we did B. No, here. C was called here. So it starts at line 7. So let me write it down. This one starts line 7. All right, what does line 7 say? C out 2. Okay, let's C out 2. We move down, we're at line 9. C out 3. C out 3. Cool, we reached the end of the program there. So this is also going to be done. Whew, let's move on to the last two processes. So the last two processes is different color. B. So when was this B called? This B's parent was A. A was called at line 2. So let's go up. Line 2 was when B was introduced. That means this B must start at line 3, right? So let me write that down. Starts line 3. And what does line 3 say? Line 3 says to C out 1, right? So let's C out 1. C out 1. All right, cool. If num is greater than 0, we fork again and we C out 2. So what's our num value? B is the child of parent process A. The child process will always have a value of 0 when it's forked, right? If this thing forked another thing, then this num value would be 1. Since it didn't, it's just 0. Is 0 greater than 0? No, it's not. So we don't enter this. We skip straight to 9, which is C out 3. So let's C out 3. We reached the end, so we can say we did B. All right, last one left. Let's do pink, because why not? C. So when was C called? C is the parent of A. So A was called at line 2. So let's go to line 2. So A started at line 2. We're not looking at B. We're looking at C. All right, C was called at line 6. So we're going to start from line 7. So let me write that down. Starts line 7. And what does line 7 say? Line 7 says to C out 2. So let's C out 2. Now we're done with line 7. We're done with line 8. We're at line 9. Now line 9 says C out 3. So let's C out 3. we reached the end of the program. So I'm just going to give a tick mark here. And we covered all the processes, right? So now we could show the possible output, right? Also, by the way, you don't have to write down the star cell line, star cell line. This was just for me because it kind of helps me, but you don't have to write that down. So when it comes to when it comes to writing down the possible output, there's many ways to do it because determinism, something like you don't know in what way the operating system will prioritize each process. So it's up to you. The thing I like to do is like I just go by the order I did it. So first, cout 1. So I'm just going to write, let's do black. This will be possible output. That's 1. Next is 2. Next is 3. All right. So I did that. Then we made 1, right? I'm here. I did this, and then we went to 1, and then in 1 we cout 1, 2, 3. Okay, we're gonna cout 1, 2, 3 there. 1, 2, 3. So this was original process. This was A level 2. You don't have to write this. This is like level 2. And this is level 3, in case it helps. The diagram is getting very cluttered, so I apologize, but I hope you guys know what I mean, right? So 1, 2, 3, that's done. After we did A, we went to B, remember? So B says to cout 1 and to cout 3. So 1, 3, this is going to be B2. Then we went to C. C said to cout 2 and to cout 3. So C will cout 2 and 3. This was C2. Let me move all of this down so it's under one line. Now, let's move on to this B. This B says to cout 1 and 3. So that's 1 and 3. And this one will be B3 because that's level 3. Non-official term, by the way. Next, we're at C. C says to cout 2 and 3. So I'm just going to write 2 and 3. And this was C3. Okay. I think we're pretty much done. But this is just one possible output. There should be another S there. Because maybe the operating system does like B2 first before A2. You know what I mean? But this 1, 2, 3 should stay together, I think. But it all depends on in what order the ready queue is processed, I think. But other than that, this is how to do a fork problem.